Hey everyone! Today we're exploring unveiling real-world wonders through Power Series, where Matt helps us uncover the awesome secrets hidden in our everyday world. Let's dive in. This is our lesson outline. First, what is a power series? A power series is a specific kind of infinite series that expresses a mathematical function through an infinite sum, and it can either converge or diverge. A power series is an infinite series that may be written as follows. Let's consider this power series. This series falls into one of the following categories. Power series representations express functions as infinite sequences of terms using variable powers, providing a valuable tool for estimating and interacting with functions in calculus, analysis, and solving differential equations. Geometric power series. A geometric power series is like a math pattern where each part comes from multiplying a fixed number by the variable raised to different powers. It usually looks like this. Taylor series. A Taylor series expresses a function as an infinite sum of terms determined by its derivatives at a point A. Named after mathematician Brooke Taylor, it is written as an equation for function f of x centered at A. Now, let's proceed to the application of power series in real life. First is power series in computer algebra. What is computer algebra? It is a branch of mathematics and computer science which involves developing algorithms and software to manipulate mathematical expressions symbolically, emphasizing exact computations with variables rather than numerical approximations. Power series in computer algebra. Power series are mathematical representations of functions that express them as an infinite sum of terms, usually involving powers of a variable. Power series are widely used in computer algebra because of their ability to represent functions in a symbolic and structured manner. Here are the key components. Formal power series. FPS are mathematical representations expressing functions as infinite series involving variable powers, commonly used for symbolic manipulation in computer algebra systems. Computer algebra systems. CAS, like Mathematica and Maple, perform symbolic computations, handling algebraic manipulations, equation solving, and formal power series manipulation. Hypergeometric type. Hypergeometric series, a unique power series with specific coefficient ratios, often features closed-form solutions and is applied in various mathematical contexts. Initial conversion process. The initial power series conversion involves transforming a given mathematical expression or function into its equivalent power series representation. Maxima Reference Manual. Maxima, an early computer algebra system, is detailed in its reference manual, guiding users through mathematical computations including power series manipulations. Rational algorithm. A rational algorithm involves manipulating power series with polynomial ratios. Simple differential equation. Power series are often used to solve differential equations. A simple differential equation may refer to a first-order or low-order differential equation that can be solved using power series methods. Recurrence equations. Power series commonly solve simple differential equations including first-order or lower-order ones using power series methods. Generalization. Generalization broadens concepts applying power series techniques to a wider range of functions or problems. Second conversion process. The second conversion may involve further manipulating power series, refining the representation, or applying optimization to algorithms. Now let's proceed to the power series in life cycle assessment. So what is a life cycle assessment? LCA, also known as life cycle analysis, quantifies the environmental impacts of a product, process, or service over its entire life cycle. Power series for life cycle assessment. The presentation applies power series and structural analysis in life cycle assessment, addressing criteria, flexibility, challenges, and emphasizing the importance of unifying scientific concepts to strengthen LCA's foundation. Power series expansion. Identify components, mathematical representation, apply power series. Conditions for power series expansion. Check norms, evaluate eigenvalues. Structural analysis. Define system structure, identify relationships, and utilize analytical tools. Number 4 is practical application. Integrate data, iterative analysis. 5. Challenges and considerations. Prioritize data quality, adapt to complexity. 6. Future directions. Explore new tools, interdisciplinary collaboration. The final one is a power series in an algorithm. What is an algorithm? An algorithm is a finite sequence of accurate instructions that is typically used to solve a specific class of problems or to carry out a computation. The power series algorithm, or PSA, efficiently computes metric in multi-queue or multi-server systems. Using Markov representation, power series expansions, and recursive methods, its adaptability makes it valuable for handling complex mathematical representations in diverse applications. Power series algorithm for derivatives. The PSA efficiently handles computing metrics and derivatives across different systems, showcasing adaptability and effectiveness in managing complex mathematical representations for various applications. Quasi, birth, and death. The QPD algorithm efficiently computes power series coefficients, excelling in managing intricate series computations for complex mathematical representations. Recursive computation scheme. A recursive computation scheme solves a problem by breaking it into smaller self-referential subproblems, solving them independently and combining their solutions for the final result. And that wraps up our journey into the fascinating applications of power series in real life. Thanks for joining, and until next time, happy exploring.